Hello guys, this is our seventh class, and last two classes we were working with the Python, writing a custom tool to generate the um, texture, the speed texture. So let's just take a look at what we're gonna accomplish today. Today we will be finishing the tool that we started in previous classes. And the goal of this class is to write a graphics interface, or GUI in short, for the tool that we created earlier. And I just opened the that simple cylinder, rotating cylinder scene. Right now there's no texture applied to it, no shader, nothing. It's just a raw piece of geometry rotating along its x-axis. And if I select the cylinder and I would execute the tool, we would be given a dialog box where information is being split into two main areas. The first area is called object info. it's a read only. It supplies us with the information about the object name, object type, and some generic information, how heavy or how light the geometry is, and it tells us it's 54 vertices or 56 faces. The second area of the dialog box is for the user to choose what file format is going to be used to generate a texture, and there are 8 choices as a TIFF, IF, JPEG, RGB, RLA, GGA, BMP, and HDR. These also the X resolution and Y resolution for the output texture size, and number of samples to be used during a baking process. And the last option here is the output folder, that when you click, it brings you into the current project, where the user would be able to pick the directory where the images will be written, or if the user prefer, right click and create new folder with the name of the choice. So let's say image output. And after the options being set in dialog box, the user would hit generate button, and as we can see, the timeline advances from a first frame of the animation to the last, and as the time frame progresses through the timeline, the image sequence texture is being written to the disk. When this process is done, the new shader is being created. The resulting texture applied to the geometry, and if we scroll back the frame time slider, we would be able to see the baked texture already being assigned to the object. So if I select the cylinder just to verify it happened, we see here is the simple Lambert shader with the file texture map assigned to the color swatch of the Lambert shader, and the use image sequence checkbox is selected in order to in order for the Maya to progress through the image sequence as the frame range changes. All right, so that's an introduction to what we're gonna accomplish today, and now let's reopen the file as it was, and you would be able to download this scene file from FTP site. And before we start discussing about the tools we're using, I already opened a Wikipedia dedicated to PyQt. And PyQt is very popular graphics interface tool for Python programming, meaning it's a very fast and convenient way to wrap your executable Python code onto the or into the graphics interface. And as Wikipedia says, PyQt is a Python binding of the cross-platform GUI toolkit, Qt. It is one of Python option for GUI programming. Popular alternative are PySide. So that's all we need to know about PyQt. I would only add that Qt is a set of commands or library of written, as I believe, in C or C++, and PyQt is the way to make that graphics interface library available in Python. And this is a quite large area of expertise and can easily take a lot of time mastering. But in order to start writing with PyQt, we don't really have to learn every little bit of this quite advanced system. All we need to know is how to start building graphics interfaces with this powerful module for Python called PyQt. In order to make Maya able to execute PyQt commands, we would need to download from a link that you see here on the screen a zip file. It's called PyQt 4.9 for Maya 2013. It's already pre-compiled. It's kind of scary word, but all it means is that it's ready to be used installer that needs to be placed into Maya installation directory under side packages. I will put a small text file into FTP folder for this class with a short description how it needs to be installed. All needs to be done is copy paste downloaded zip file into side packages directory found under Maya default install directory. And after that, restart Maya and you're ready to go. You're ready to start creating graphics interfaces. You usually start graphics interface programming with PyQt by importing PyQt4 module. And this is predefined command from PyQt4 import Qt core Qt GUI. And if I control enter, I'm not receiving any complaints from Maya, no error messages, meaning everything went smoothly and Maya was able to find a PyQt library that you would have to place or copy paste into side packages. The next line of the code that we need to establish, and those are quite standard, is here that I've just copy pasted into my script editor. Upon execution of those two lines, nothing yet will happen. All we did is just register so-called Qt GUI class from a PyQt module. Then we would define a class itself. This time we define our own class. We call this class user interface, UI for short. And this is kind of, you can take this as a standard recipe. Every time you put together a dialog box, just a copy paste, keep using this every time there is a need to create a dialog box. And what it will give us, let's take a look. Those just like a 25, 29 lines of code would give us a simple window. And you can see that the only customization to this window that we made is we defined the size of this window being 640 pixels wide and 320 pixels height. And we also gave it a custom title, which is in this case fx PHP Maya 217 generate velocity texture. And we achieved that by supplying string argument, the name, the title itself, to set window title command. It's the last line of this code. So if you'd like to, we can really briefly stop on every line here, and just to get an idea what actually happening here is that first we create a layout which is kind of required, and this layout is like a highest in the hierarchy of all interface elements. Every interface element in PyQt is a kind of class by itself, and we need to connect as we build those graphics user elements. We need to connect them to each other. So let's say first we create a widget, and then we create a layout, and then we link them together. Next example here that is slightly more complex comparing to the previous one is that we introduce a couple buttons here, and for this purpose I have already predefined a script which is exact copy of the script we just looked at, except of generate and cancel buttons added to this dialog box. So what happened in here is that after we establish a main layout here, which in our case we capture into the, first we establish a dictionary widgets. It can be really any variable of your choice. It doesn't have to be a dictionary. I prefer working with dictionaries because this way all the information, all the data is being stored in the same variable that easy to pass along or send from one function to another. And for each widget I define a key, and with kind of meaningful, easy to recognize keyword. So for example, for the cancel button, I would give it one key name. For generate button, another keyword. So for example, in this particular case, a cancel button receive a cancel button key for the widgets dictionary, and generate is a receive and generate button, and so on. After those two widgets, as we call it, so the buttons are the widgets, really, just like everything else in PyQt. After those two widgets, two buttons created, those widgets needs to be assigned to layout. So idea is that all graphics interfaces such as the fields, buttons, sliders, checkboxes, and so far, they all need to be assigned or parented to layout. And so layout is like a page or placeholder for those widgets to recite on. And then layout itself is being assigned to a group box. So once again, it's kind of important to understand is that first we create a widget called group box. Next, we create a widget which is called layout. Layout will be a child of the group box widget. Then we start creating all type of graphics interfaces, such are not graphics interface elements such as buttons, sliders, fields, spin boxes, and so far. And every widget that we create, we will be assigned as a child to layout, which is in its own turn is a child to the group box. The group box is the parent of an entire hierarchy, where layout is the next ancestor and individual elements, graphics elements, are child for the layout widget. The group box itself also needs to be parented under the main layout, and the main layout is being parented under the main group box. So I put those two lines here, like a comments lines, to isolate that portion of the code from the rest of the code, so you would be able to see that how this repetitive pattern will happen when dialog box becomes more complex. So let's just execute this thing again, and if the parent of every widget here is the window itself. The layout you could visualize by this black border running along the main window. The button itself are the childs for this black bordered layout. The layout is a child of the window itself. So that's how actually any even most complex interfaces are being done using PyQt. So here in our previous class, we end up writing an executable core, which, as we remember, started as simple as determining what object is being currently selected. And I just copy paste those few lines of the code that were responsible for determining what object is being selected. And for that we use cmdsls list selection with the flag true. And next we use the cmdsls command to capture whatever is being selected in my session. So if I execute this portion of the script and then print out the result of this command that was captured into the selection variable, we would be able to see that the result of the cmdsls command is the name of the transform node of the object. And then we would go through the verification process to determine whether it's only one object is being selected. The next line of the code was intended to extract or receive a name of the shape node that we need to manipulate shader assignment later. And the only difference in this particular code is that instead of using different names for each variable, I just declare dictionary DIC, and I just would, instead of using a variable with different names, I would just use different keys for this dictionary. This way, it's my preferred way to deal with the variables, and I find that dictionary is extremely powerful when it comes time to exchange data between different functions. Okay, and next we would use a simple line of the code to verify that the object is the mesh, because for our tool to work, the selected object must be a polygon mesh. Then we would go on and find out or gather the information about how many vertices this object has, how many faces, and how many UVs. But instead of capturing this information into the dictionary, I keep using the old-fashioned way of storing this data into the dedicated variables. And so if I execute this, in all of those all 3 lines of this portion of the code use the same Maya command called polyevaluate, just a different flags. And then once again we verifying or confirming that we're moving through execution of the code properly, dealing with the right piece of geometry is kind of important, because if we forget to do that, we might get ourselves advanced too far into the script execution and yet the piece of geometry we're dealing with is not valid, could be not valid. Here we verify that the object's got UVs assigned, because for this tool to work properly, UV needs to be present on the object. Then we query MyScene for the first and last frame, and so far and so far. So we covered the content of executable portion of the code in the last class, and you clearly see that there's nothing new happening here, other than instead of using different variable names, I switched to single dictionary. So I'm copying and pasting entire portion of the executable part of the code into the new Python script here. And as you can see, it starts with the declaring dictionary variable at the beginning, and then entire code goes line by line as we created it in the previous lesson. The next 3 lines that follows immediately after this executable portion is I'm declaring object details key dictionary that when executed would create and if I print out just a simple string that is assembled out of the word vertices and then variable vertex count that by nature was an integer, but since string conversion was applied, could be used with the other strings in this simple math here. And then I declare the list where each file format is being listed. That list will be used later as an argument to be passed to the graphics interface and to populate the pull-down menu for the image format options. The same goes with the bit depth and output directory. For the output directory, I'm using a mel command workspace to query current project, and that would be a default choice for the user to pick up from beginning. Next, I would have to rewind to the beginning where PyQt class was initiated. Before it could be done, I make sure that all the modules are being imported, and as we discussed this earlier, the modules being imported at the beginning of the script. Then in order to build the graphics interface, we declare the class and PyQt class where we will assemble the dialog box itself. And I already showed at the beginning of this class how at very simple form it could be done. And what I'm about to create here is exactly the same dialog box except with more widgets in it. And as you can see, it starts with the same declaration, and the syntax for this declaration is kind of predefined. What happens next is that I receive a dictionary that I pass along from a main executable portion, and I capture and redeclare it with the local dictionary preceding with the prefix self. I also establish a subfunction inside of the main class UI class that will be responsible dealing with closing the dialog box. And then there are a few local functions. One of them is to be linked to browse or navigate button. One function to be linked to push button or OK button. And the main function here, as I call it for myself as a main, is called a build GUI, where all the widgets are to be created. And while they appear to be a little complex, in reality it's all the same repetitive code happens again and again. And let's see how we could simplify the process of understanding of building the interface. So first of all, I establish a main layout. It happens only once. Then I establish or create a main queue widget. It also happens only once. So those three widgets here, they are like the topmost hierarchy of graphics interface, and everything else below it just goes into same predefined pattern. First you create group box, then its immediate child form layout. Then you create a widget such as for this particular case a line edit or a comment, a label, and then you define certain qualities to it, such as you give a background color like it happens here. You populate the line edit with a string value. Then you move on to the next widget. You define its properties. You define its color. You give a field value, or you make it enabled or disabled. Then to the next widget in that particular area. And when you're done creating with widgets, you assign all of them to be a child of the queue form layout that was created earlier. And you would use a command that called add row and the name of the widget in a parenthesis. And then when that's done, the layout and group box themselves needs to be parented under the main widget. And then we move to the next portion, repeating exactly the same steps. First we create a group box, then its immediate child queue form layout, then we create one widget, and after another widget, and then when you're done with those widgets, you assign them to layout, then you make layout child of the its parent and so far, and then you move on to the next and next. So that's how, for example, this dialogs box is made of. The windows, the main window is being created, the object info layout created first, and then object name label created, and then a field here, which is a text edit, it's called in PyQt. Then another label object type, it's called here, we call it object type, is being created. And lost the dialog box here. And then it's been all three of those, so there were three labels created and three fields, edit fields, and they all were assigned to the object info layout. And object info layout was assigned as a child to the main window. Then we continued to create an texture option layout, and then we created a texture type label, then combo box that would store the images extensions that we defined in variable txt format key variable. And then we created X resolution and Y resolution labels corresponding edit fields, and then a spin box here. We define with the spin box we define the maximum and minimum values, so the user would not be able to dial a number that is too large for the sample to be received, and so far. That's how we arrived to the end of this dialog box. And then the rest was pretty easy. All we had to do is to link OK button to executable portion of the code. And for this purpose, if we go back down to that area where we define generate button, then we would be able to see that by using this simple statement, we were able to link clicked action of the button to our own function. And in this particular case, the function is called to be a push button function, and it's once again linked to the action that is being registered by PyQt with the name clicked. And if we would like to see what exactly happening when push or clicked action happens, we would need to go and take a look at the push button function itself. And as you see, is that first what happens is that we read whatever values are being stored in corresponding fields, such as like object name, object type, object details, whatever choice was made by the user dealing with those pull down menus and numbers. So whatever was registered with this dialog box, we capture and assign into the dictionary variable. And then when we already gathered all the information we need to proceed with the texture generation, we start executing those commands line by line. So first, what we would like to do is to create a bake set. And a bake set, as we know from a previous lesson, is required for mental ray to generate texture based on the color per vertex information. And those texture sets or bake sets, those are nodes that we use to define output resolution in X and Y, number of samples, and a bit depth for the image, as well as a texture file format. And then another function, if we'd like to take a look at the functions themselves, they are at the top of the code. So that's first of all is a create bake set. This function receives a resolution X, resolution in Y, number of samples, bit depth, and texture variable as the arguments. When the function receives those values, and once again those values were read from a dialog box from the user that typed them in, we first of all convert the values that were used for the human user into machine indexes. Then Mentoray was code to work with. So instead of, for example, using an 8-bit per channel or 16-bit per channel, Mentoray uses an index of 1 for 8-bit per channel, 2 for 16-bit per channel, and 4 for 32-bit per channel. And same goes with the file formats. So for the TIFF, it's index 1, for IFF, it's index 2, and so far. The number of samples goes directly as they were being typed, with one only exception, that they must be integer numbers. So that's what happens here. So we create a vertex bake set and texture bake set, and then we modify their attributes using those predefined variables. Then we create a bake shader, and once again we supply this function with the object name and object shape name. And then the last function would bake the color information into the texture. Aside from baking in the color information into the texture, this function also renames generated texture into something that we specify in this portion of the code. And one particular attention was made to give the image sequence or each image in the image sequence frame number. And we're using quite popular approach that could be easily seen in Nuke. This is a %sign of 4D to give a 4-digit number for the frame pattern. And then we return the last frame of the image that was generated back to the push button function. This variable is needed later to create a shader and assign animated texture to it at the end of the procedure. And actually, as a matter of fact, if we take a look here, image file variable is used to capture that information back. And then the very last 3 lines of code deals with cleaning up everything that we don't need at that point. First of all, we delete the polygon color set that we use to pass speed information to the texture. Then we select and delete the bake shader that was used by the same process. And the last function that we call create assign shader, and we pass object name, shape name, and image file. In this case, image file is the last image of the image sequence, to that function to do to create a shader, Lambert shader, to create an image texture and assign it to the object, so we would be able to see. One thing that happened in the very last step is that I found it was important to assign, let's say here, to assign the or to select the file node itself as the last step of the execution for Maya to be able to display the animated texture images in OpenGL viewport. So that actually concludes 3 lessons long class on a Python programming, and I hope that you were able to get kind of fundamental knowledge of how it's been achieved, how the tools inside of Maya being programmed with Python, and the rest in order to master the programming itself. That would require just sitting in front of the text editor and putting a line after line with a goal to produce a piece of code that does not fail and quite robust and efficient. Thank you very much, and see you next week.